Hi everybody. Today we are going to do the Geometry Chapter 4 practice test. First question. Identify the exterior angle. Remember, exterior means outside, so I want to look for an angle outside. The angle that I'm highlighting is the exterior angle. Remember, we can name that GED, or we can name it DEG. So look at our choices. We want to go with B. B would be the correct choice. Next, given that angle M is congruent to angle H, and that side MN is congruent to HI, what is the third congruence which is needed to prove that triangle MNO is congruent to HIJ by angle, side? So first I'm going to draw two triangles so I can visualize this problem. M, N, O. Then I'm going to draw the second triangle. It's going to look very similar, and then I'm going to name it the same way I did MNO. So I'm going to start here and name this HIJ. So it says angle M, so I'll mark one arc for M is congruent to angle H, and MN, this side, one tick mark, is congruent to HI, one tick mark. Now it's got to be angle, so I can't put my angle here because then it would be angle, side, angle. So I want to put my angle right here on angle O, and angle O corresponds, is congruent to J. So if I have it now, angle, side, angle, side. So I need that angle O is congruent to J, which would be choice A. Which method can be used to prove the triangles are congruent? So I want to look at the markings again. So I have an angle, I have another angle, and then I have a side. So you might want to mark that out as you go. You have an angle, you have an angle, and you have a side. Here, if I start, since I started here where there was two tick marks, angle, side. So which method am I going to go with? I'm going to go with angle, side. Which method can be used to prove the angles are congruent, the triangles are congruent? So I have angle, side once again. Again, I have angle, side. So the ones that can be proven congruent, angle. When I like to do these, I like to draw my triangles like I did in the previous problem. So I have triangle DEF. Now remember how we named that. And I'm going to draw the second congruent triangle, which is RST. So what is congruent to RT? Well, since RT, in my congruency statement, is the first and last, over here I want to use the first and last, which would be DF. So I want to go with choice D. Make sure you fill that in. I have to find X and Y. So I'm going to find X first, and I could tell that this is the exterior angle theorem. The exterior angle theorem says that the exterior angle is equal to the sum of the two non-adjacent. Y is the adjacent angle. These two are the non-adjacent. So I got 3x plus 54 is equal to 4x plus 4. Or sorry, 4x plus x. These are like terms, so I'm going to combine my like terms before I do anything else. I'm going to bring down the left side of the equation. Since solving my equation, I want to move my 3x over here since this is the only variable on the right side. So I subtract 3x from both sides. They cancel out now. I bring down my 54. 5x minus 3x is 2x. Divide by 2, divide by 2. 27 equals x. Now that I know that 27 is x, right? Could plug it back in here. That means this angle is 27. And if I plug it in here, 4 times 27 is 108. Now I could find y using the triangle sum theorem. So if I add these three up, 27 plus 108 plus y, those three angles of the triangle should equal 180 degrees because there's 180 degrees on the inside of a triangle. 27 plus 108 is 135, so combine your like terms. (180 minus 135) y is 45 degrees. 1, 2, 3. BCD. BCD. This was a 213. That doesn't work. DBA. DBA. 312. DCB. 1, 2, 3. DAB. 2, 1, 3. DCB. 1, 2, 3. BAD. BAD. 1, 2, 3. Right, just like we had back here. DCB. 1, 2, 3. Oh, that is the correct one. So let's see how they're named. We got CSQ. So I'm just looking at the arcs. So I got 0, 2, 1. So I'm going to, this was 0, 2, 1, RYM, 0, 2, 1. So this is the correct one I'm going to go with. But I'm going to check these other ones. So I got 0, 1, 2, MRY, 1, 0, 2. So you see how they don't match up just based on the markings. YMR, so I got 2, 1, 0, 2 arcs, 1 arc, 0 arcs. QSC, QSC would be 1, 2, 0, so they're not in the same order. YRM, so we got 2, 0, 1, and SQC. SQC is 2, 1, 0, so they're not in the same order. The only one that was the first choice. Let's look and see how this is marked up. AMD, so I got A, one arc, M, 2 arcs, down to 0 arcs, so 1, 2, 0. So the same way would be HFR. HFR. Let's see our choices, and we're going to go with HFR. HFR right there. That would be the correct choice. Sides and angles. So by sides, I'm going to fill in my third angle. I'm going to use triangle sum theorem. So 53 plus 32 gives me 5, 85. 180 minus 85 is 95. So this triangle has an obtuse triangle, so I know it, since this angle is obtuse, this triangle is obtuse. And looking at the opposite, right? If none of the angles are the same, that means none of the sides will be the same length, right? So if none of the sides are the same length, that means it's scalene. So if you have two angles that are alike, you'll have two sides that are congruent. If you have three angles that are the same, you'll have three sides that are the same. So this is a scalene obtuse, and we just wrote it backwards. So obtuse scalene is the answer you want to go with. Know that Z is the same as C. C and Z are the same. So I'm going to use triangle sum again. I'm going to add up 73 and 47.
That gives me 10 carry the 1, 8, 12. That means C, after I subtract that sum from 180, is 60 degrees. So if
C is 60 degrees, that means Z is also 60 degrees, because from your congruence statement, A is congruent to X, B is congruent to Y, C is congruent to Z. These first two side lengths were just extra, just trying to get you confused. We want a method. I have another reflexive side. I have a right angle, so I start thinking hypotenuse leg. Let's see. Well, the side opposite the 90-degree angle, this is the hypotenuse. I abbreviated HYP. And I have a reflexive side, which counts as one of my legs, because the legs are the two sides of the right triangle that make the right angle. So this one is going to be hypotenuse leg. Which method can be used? Well, since these three sides and these three sides are all marked congruent, that's the easiest one in my opinion, side, side, side. Correct congruence statement, again, since my angles are marked, I'm going to use that same method that I've been using, and I'm just going to write the number of arcs above it, so 1, 0, and 2. So, and then I'll see which ones line up. So FWT, FWT, so 0, 1, 2, 0, 1, 2. NDK, 0, 1, 0, 2, 1. No good. KND, KND would be 1, 0, 2. FWT would be 1, 0, 2. So this looks good, but I'm going to check the other one.
Just to make sure I didn't make a mistake. KDN would be 1, 2, 0. TFW would be 2, 1, 0. So they don't match up. DNK would be 2, 0, 1. And FTW would be 0, 2, 1. So they don't match up.
So B is my correct answer. I could tell this is an isosceles triangle. So angle BAC, remember A is your vertex. Sometimes we don't name these correctly. So I'm starting here at B. A is my vertex. I end my angle at C. That's an angle. So my 82 is my vertex angle, because the vertex angle is where your two congruent sides meet. Where the congruent sides meet the third side, these are your base angles. So an isosceles triangle, these angles are congruent. So I'm going to do 180, subtract the vertex angle, 82. I get 98 degrees. The 98 degrees is for both of these angles, so I'm going to do 98 divided by 2, and both of those angles are 49 degrees. So my choice A, 49. Again, I'm going to look FPG. I'll number these according to tick marks. So I'm going from F to P. F to P is 2 tick marks. Then P to G is 1. And G to F would be 3. So I want to number that 2, 1, 3. So 2, 1, 3. 2, 1,
3. So I did D, V, B.
So the correct one would be DVB. Another isosceles triangle, right? Well, this one's sort of reversed. Before they gave me the vertex angle and I worked my way to find, I subtracted this from 180 and then divided what was the difference by 2 to find out these two base angles. Now I know the base, so I'm just going to really do the reverse process. I'm going to take 66 and multiply it by 2 because I know x is 66 over here because these two are the base angles where the congruent side meets the third side, or opposite, opposite the two congruent sides. These if you're opposite this side, these angles will be congruent because they're opposite the congruent sides. I have 132 degrees.
Now if I take that and subtract it from 180, I will get...
if you want to do some borrowing, 48 degrees. So y is going to be 48 degrees. This one's not hypotenuse leg, even though it's a right triangle. I got a side, then the angle, then the side. Side, angle, side. So what am I going with? I'm going to use side, angle, side. Not hypotenuse leg, because the hypotenuse is not marked congruent. I know I like to think as soon as I have a hypotenuse, or as soon as I see a right triangle, I want to think hypotenuse leg, but not in this instance. Again, another isosceles triangle. We're working backwards like we did. ABC, ABC, ABC. B is the vertex, so that's where I want to put my angle measurement. With that being said, I know that angle C, like this, is 55. Maybe I'm not really reading. I gotta just look. I'm looking for BAC. So I gotta find this angle up here. This is the one we're looking for.
BAC. See where the vertex is, that's where the angle goes. Alright, so this one's 55, that's 55. So 55 plus 55 is 110 degrees. Use triangle sum, subtract the 110 from 180, because all triangles add up to be 180. 180 minus 110 is 70 degrees.
Complete the congruent statement. So we got WAQ. Again, I could look at this and I could number the arcs as we go along. So WAQ is 1, 0, and 2. So that is one arc, that has no arcs, that has 2 arcs. So I want to do it the same way. So I'll start with L, go to G, and to D. 1, 0, 2. So L, G, D. All right. SR and MT intersect at the midpoints. So if these two intersect at the midpoints, that means that this segment, SA, is congruent to this segment over here, AR. So I put 1 tick mark on each of them. And if this gets intersected at the midpoint, that means MA is congruent to AT. Now, that's only 2 parts, and the only one with 2 is hypotenuse leg, and this is not a right triangle. So where's our third piece that we need? I call these kissing triangles. And like we learned in chapter 1 in the very beginning of class, these are vertical angles. So that means this angle is congruent to that angle. Let's see what we can do now. We got
side, angle, side, side, angle, side. And over here, if I start on this line with the 1 tick mark, I got side, angle, side. So MA is congruent to
AT. That's true. Triangle MAS. Now watch how it's marked. MAS. 2, then your angle, then 1. 2, 1. Okay, TAR, 2 angle, then 1. Okay, that's true. Got to really pay attention to how the triangle's marked. Angle AMS, all right? AMS, so you're looking there. M is your vertex. ART, no. That is not true. That's false. If you remember back to chapter 3, right? If you think of two parallel lines, and this is the transversal, this angle, I'll do 2 arcs this time, would be congruent to this angle because of alternate interior. Like I'm picturing 2 parallel lines up here. So if this angle is congruent, that means S, angle S here, so like MSA would be congruent to ART. I need 3 arcs. I didn't realize that because I already used my 2. So now angle MAS is congruent to RAT. That's true because they both have the vertex A, they're vertical angles there. They're vertical angles. So MAS, that's true. So the only thing that's false here is the AMS is not congruent to ART. Which method? Well, this looks like a classic case of angle, side, angle, right? I have my angle, then my side, then my angle. Angle, right? Tick marks or arcs line up, 2, then your side, then your 1. So angle, side, angle, angle, side, angle. I'm going with angle, side, angle. Looking here, before I do anything, this reflexive side, I can mark it congruent, right?
Let's see how we're, by tick marks, I'm going to do 1, 2, 3, not angles this time. So I'm starting at U.
I go to M, so it's going to be 2, 1, 3. So this is 2, 1, 3. DUR. That's 3, 1, 2. DUR.
3, 1, 2. They don't line up, right? They don't match. DMU. 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 This is going to be 1, 2, 3. UDR. UDR. This is 3, 2, 1. Not working. DUM. DUM. So it would be 3, 2, 1. So we need this one. That would match that one. So it's not the same. DUR. So we got 3, 1, 2. 3, 1, 2. MUD. 2, 3, 1. 2, 3, 1. RDU. 2, 3.
1. Oh, I was getting nervous. I wanted to make sure that we got one. I don't think any answer has been D so far. So the third choice there, or fourth choice on mine, I don't know if you'll have the same. But MUD is congruent to RDU. Well, I think this is going to be it for us. Looks like the last problem. You've been great company. I'd like to thank you for hanging in. I hope this helps, and I hope you do well on your test. Which method can be used to prove the triangles are congruent? Triangles are congruent. Well, it looks like angle. This isn't a great sketch, but I got angle, side, angle. Over here, I have angle, side, angle. So I'm going with angle, side, angle. All right. So you submit that, and thanks for hanging.